Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2009 B version Calculus BC question number 3. This question also had a cameo appearance on the Calculus AB exam of the same year, and it reads, a continuous function f is defined on a closed interval from -4 to 6. The graph consists of a line segment and a curve that is tangent to the x-axis at x equals 3, as shown in the figure above. On the interval 0 to 6, the function f is twice differentiable, with f double prime of x being greater than 0, so meaning we're concave up. Awesome. So the first question is f differentiable at x equals 0? And it says use the definition of the derivative with one-sided limits to justify your answer. So before we begin this, let's go and talk about the definition of the derivative again. There were two versions of it. It was the limit as h goes to 0 of f of x plus h minus f of x over h. And we generally used this guy to find general derivatives, just kind of the slope anywhere. There was the other one, which was actually more preferred for derivative at a point, which was the limit as x goes to a of f of x minus f of a over x minus a. Now, because they're asking me for differentiability at x equals 0, I feel more inclined to use this version of it because this points more towards a point. So we're going to use the limit definition of the derivative with a one-sided limit to justify the answer. So I'll go ahead and actually move a up here. So I apologize for putting a all over the place. What I'm going to do is I'm going to say, first off, let a be any point on f of x. And what I'm going to do is I'm going to say, okay, the limit as a goes to 0, I'm going to say f of a minus f of 0 over a minus 0. So what am I doing here? Well, I'm letting a be any point, and I'm letting the distance between a and 0 get infinitely close. Now, I want to do this actually just from the left side, because from the left side, I'm going to be looking at this line right here. Now, this line here, the slope is positive 2/3. If you do your integrated one slope, it'll become 2/3, but more importantly, this thing is positive, right? It's a positive slope. Now, if I do the exact same thing, if I say, all right, the limit as a approaches 0 from the right of f of a minus f of 0 over a minus 0, well, unfortunately, they just told me it was a curve, and I could try to assume it's a half circle, but it doesn't really look very circular. But it doesn't matter. It doesn't matter what type of function it is. All I know is that this slope is negative. And so since these guys don't match, I'll even write this down, negative. And since these guys don't match, what I can say then, I can then say that therefore f is not differentiable at x equals 0, because the slopes don't match each other on either side. Okay, so let's go ahead and move down to B. It says, for how many times a on the interval from -4 to 6 is the average rate of change of f on the interval a to 6 equal to 0? Give a reason for your answer. So from here, let's go ahead and find out what the average rate of change is on the interval a to 6. Well, average rate of change is going to be f of 6 minus f of a over 6 minus a. That's my average rate of change, right? And I want this thing to equal 0. So what I'm going to do is I'm actually going to go and solve for this f of a real quick, because I don't know what f of a is. Well, from here, that's going to go away. F of 6 minus f of a is equal to 0. So from here, I'm going to go and add the f of a to both sides. So f of 6 equals f of a. But I do know what f of 6 is. F of 6, according to the graph, is 1. So let's go and talk about the significance of this statement right here, because we're not done yet. What this is saying is basically when f of a is equal to 1, in other words, when the graph of f intersects with 1, that's going to be when my average rate of change is 0. So we all know what the graph of 1 looks like. He's just a horizontal line. And since they want me to do it on the interval from -4 to 6, I'll go and just draw a horizontal line there and it's going to absolutely intersect twice. Now, I'm not going to include the 6 because they don't include the 6 in the original question. So all I can conclude is that the graph, I'll even write this down, the graphs of f and y equals 1 intersect twice on 4 to 6. Therefore, the average rate of change will equal 0 2 times. It's kind of a weird question right there. Hopefully that makes sense. Let's go ahead and clean up the board, and I'll move on to C. Give me a second. Part C is a very strange mean value theorem question. It says, is there a value of A on -4 to 6 for which the mean value theorem can be applied to the interval A to 6? So what they want is they want to say, hey, what intervals will the mean value theorem apply to? Well, it says, and we want to guarantee a value C for which f prime of C is equal to 1/3. Well, this is really important because if you notice, we want our instantaneous rate of change to be positive. Well, I'm looking at the graph right now. I can already see of a very large region of the graph where the MVT would not apply, and that would be from -4 all the way to 3. Let's talk about why. We can say the interval will exclude, let's see here, -4 to 0 because f prime of x is equal to 2/3, right? Remember, it's a linear equation, so the slope is constantly 2/3, so there's no way it's going to be 1/3 there, so we can totally disclude -4 to 0. We can also exclude, as well as, the interval from 0 to 3. And again, notice how I did not include it, as well as 0 to 3, because f prime of x is negative there. So that means that the interval at which MVT will apply is 3 to 6. That answers the first question. A has to equal 3. In other words, A must equal 3. So on the interval 3 to 6 is going to be where we apply our mean value theorem. So from here, is there on the interval 3 to 6, so on 3 to 6, can we apply MVT and find a slope of 1/3? Let's justify our answer. So let's go and find the average rate of change right there. So the average rate of change is going to be f of 6 minus f of 3 over 6 minus 3. Well, that's 1 minus 0 over 3, which is 1/3. So we can say, because f is twice differentiable and continuous on 3 to 6, by MVT there exists a value C on 3 to 6 where f prime of C equals 1/3. So that MVT question right there was all about learning how to disclude the values that you don't need and then finding the MVT value on the interval that you did need. All right, part C, that was really odd, but part D is pretty straightforward. So it says the function g is defined as g of x is equal to that thing. And they're saying on -4 to 6, what intervals is the graph concave up? Explain your reasoning. So let's go ahead and find out. Concavity deals with the second derivative, so g prime of x is equal to f of x. And then that means that G double prime of x is equal to F prime of x. So, in other words, where F prime is positive or where F is increasing. So where does that happen? Looks like from -4 to 0 and 3 to 6. So since we made that established relationship, we can say on -4 to 0 union 3 to 6, G is concave up because you could say G double prime is positive, or you could say because G prime is increasing, or you could say F is increasing. Either one of them is okay because we made that established relationship. So that is it for this FRQ. If you have any questions, go and leave them in the comments area, and I will see you all in the next episode.